Hi all the students of 9th standard. Today here I am in front of you all to discuss work power energy assignment number 21. In this assignment, let us go through the first question. Here your first question is, a spring of force constant K is stretched by a small length x. The work done in stretching it further by a small length y. Now let us try to solve this question. In this question, given data, if you would like to take it, now here the given data is nothing but a spring of force constant K is stretched by a small length x. Okay, let us take a spring over here. Imagine there is a spring like this, and you do one thing, you extend it for a certain distance x. Again he asks you to extend it little more length, that is x plus y. Imagine the first stretch is L1, second stretch is L2. Now here he wants the work done, for this extra stretch, further stretch, not the whole thing. Here the work done is question mark. How much is that work done in stretching it further for another small length of y, Now when you want to find the work done at that particular point, then what you will be doing is, so work done by the spring is W is equals to half K x square. Instead of this x square, I will be writing L2 square minus half K L1 square. Now we will take half K L2 square minus L1 square. Now if you substitute these values of L2 square is nothing but x plus y whole square minus x square. So the next step over here is going to be a plus b whole square. It is in that form, so we will try to substitute that values like a plus b whole square. So it is going to be half k into x square plus y square plus 2xy minus x, right? So from here, if you try to solve this is x square, so you will be getting half k x square and minus x square gets cancelled. You will be left over with, you take y common from these two set, and you will be getting 2x plus y. So your work done in stretching the spring further another x distance is nothing but half k y into 2x plus y. So your option is fourth option. Okay, fine. Let us go with the next question. Here, your next question is in this way. Let us see your next question. A body of mass 1 kg is dropped from a height of 5 meters. Let us take this is a body of mass. How much? Of mass 1 kg. It is dropped from a height. What is the height? It is dropped from a height of 5 meters. It is dropped from a height of 5 meters on the ground. If the body penetrates through 2 centimeters, that means this is the ground, but it just got penetrated inside for 2 centimeters, which is nothing but, if you convert it into meters, you are going to get it 2 into 10 power minus 2. 10 power minus 2 meters. So your total length over here, that means total distance which this body has traveled, is 5 meters plus 2 centimeters. It is going to be somewhat around 5 meters plus 0.02 meters. It's going to be equal to 5.02 meters. Right? Now, you got the total distance which it has traveled into the ground. The average resisting force offered by the ground on the body is. Resisting force means opposing force. This ground is applied on this body is force. So here I will be doing it, force into displacement will be equal to the work done, which is nothing but I'll equate it with the energy. Instead of this mgh I am going to take. Now here in this I need to find out the resisting force, the average resisting force which is offered by the ground. Now how do I find out my this thing is, my displacement in resistance is 2 centimeters. So in the place of displacement I am going to put 2 into 10 power minus 2 meters. So here m is 1, g is, will take it as 10, gravity will take it as 10 into height 5 centimeters, 5 meters. So actually this height is a total height. So I am going to take 5.02 meters as my total height, 0.02. Now what happens over here, when you try to multiply it over here, you are going to get, see, I want f from here, I leave this f over here and I am going to send this completely this side, which is going to be 50.2 by 2 into 10 power minus 2. So if this 10 power minus 2 goes up, you are going to get somewhat around f is equals to 5020 by 2, which is nothing but 2 ones are 2 is 2 5s are. So you will be getting 2510 newtons. 2510 newtons. So the resistance force that it is offering you, that ground is offering you, is the force with what it is coming, and it is another 2 centimeters also it has come. So that means the total length if you are taking, then your force which this ground is applied to resisted is 2510 newtons. So that is option number 1. Hope this is helpful. Let us go with the next question. Your next question, a mason worker throws the bricks to a height of 10 meters. So he is throwing a brick to a height of 10 meters at which the brick reaches with a velocity of 6 meters per second. The percentage of energy he is wasting is nearly. So they want to calculate what percent of energy is wasting over here. So initially imagine a person who is throwing a brick to a certain height of 10 meters. Okay, I am going to draw it like this. When he is throwing a brick up to 10 meters height, okay, initially he will be having a kinetic energy. Okay, so he will be having half mv square over here, at which the brick reaches with a velocity of 6 meters. So they gave you velocity also. Percentage of energy is wasting. So in that case we will take see, first of all we will take it as half mv square, and when it reaches to a certain height of 10 meters, then he is going to have both the energies. Like let us assume at that particular point of 10 he might be having mgh plus half mv square into, you want the percentage, so you multiply it with 100. Now if you take half m common, you will be getting it. So that is the percentage of energy wasted, and if you try to solve this, you will be getting half m. If you cancel from here, half m, I'll write it clearly, half m into v square by, if you take half m common, you will be getting 2gh plus v square into 100, right? Half m gets cancelled, so you will be left over with v square by 2gh plus v square into 100. So your v square is how much? 36. Here also you will be getting 36. Okay. So G is how much? You can take it as 10. Height is given as 10. Just a minute. 10 into 36. So now how much you are going to get? 36 by 200 into 36 into 100. So if you try to solve this, you will be getting energy he has wasted is nearly around 15 as your answer. So the energy wasted over here is 15%, right? So I hope this is helpful for you. You can solve it and you will be getting 15. And let us go with the next question. So the next question over here. A body is projected vertically up with a certain velocity at a point P in its path. The ratio of its potential to kinetic energy is 9:16. So he has given you a potential energy to the ratio of kinetic energy as 9 by 16. So total energy in that isolated situation is 16 plus 9, 25. The ratio of velocity of projection of velocity at P. Okay, a body is projected vertically up with a certain velocity. It is projected up with a certain velocity and it is at a certain height. Now, when you consider that thing, you cannot find out the velocities directly when you use a potential energy. So we'll try to convert it into kinetic energy. So anyway, we know at that particular point, kinetic energy at that particular point is, let us take KEP. And imagine when he is throwing it up, his initial kinetic energy be KE1. At this particular point, his kinetic energy be KEP at the point P. So you try to figure out that KE initially, which is this one, KEI. Now how much you will be getting over here? KEP. KE at that point is given as 16, and initially when you start, you are throwing it with some kinetic energy, then that kinetic energy is going to be the total energy which you are trying to throw it at the bottom, because potential energy is going to be 0 at that bottom. Only kinetic energy is going to be present, then that is only going to be your total energy. So that total energy is nothing but 16 plus 9, you will be getting 25. So there you will be having 25 as your total energy when your body is starting to lift it up. So now let us write it as half mv square mvp square by half mvi square is equals to half m gets cancelled, 16 by 25. 16 by 25. Now this is nothing but it is going to be equal to V implies Vp square by Vi square. Now this is going to be equal to square, if you send that side, how much you will be getting? If you send square that side, you will be getting 4 by 5. So I want the ratio of VI, this is VI is to VP. That means VI is 5 and VP is 4. So the amount of potential energy at that particular place and the kinetic energy, see, if you have potential energy over there of somewhat around 9, then the rest of it would be after 25, the rest of it is kinetic energy, and that kinetic energy is figured out over here, which is in the form of 4 over there at that particular point, and initially it is of 5. So your ratio VI is to VP. That means if you compare the ratio of kinetic energy from the starting to the ending, then you will be having 5:4. That means your option is second option, which is 5:4. Hope this is helpful for you. Let us meet in the next assignment. Bye.